Hello everyone and welcome back to the Winter Data Meetup. I hope you are all enjoying the insightful talks and discussions we had so far. Meet Deep, lead data engineer, and he shares his insights about data quality in his talk. Explore how tools like Databricks, PySpark, and AWS Deequ can help improve data quality and gain actionable insights. Don't miss this change to boost your data skills and excel in the world of big data. Now, before we all dive into our next session, I'd like to take a moment to ask for your support in helping us grow in our community and recognize the speakers. Firstly, if you enjoyed the content we are providing and want to stay updated on future events and talks, please consider hitting the like and subscribe buttons below this video. Now, for something a bit special, in the video description below, you will find the link to the talk page where you can provide your feedback on this talk, give speaker a badge, and rate the session if you like or if you don't like it. Through the talk, if you have any burning questions or insights you'd like to share, don't hesitate to type them in the chat box in YouTube on their community platform, depending on where you are watching us. Our team will be monitoring the chats closely and will collect all the questions to discuss with the speaker after the presentation. And now, ladies and gentlemen, let's welcome our speaker to share his valuable insights with us. Deep, floor is yours.
Thank you, Alexander. Welcome everyone today. And our topic for today's discussion is navigating big data's quality quest with cutting edge tools. My name is Deep Kulshrestha, and before we deep dive into the topic, just few words about me. That Just a sec. Yeah. Uh, Yeah, so I'm working as a lead data engineer in EPAM and worked on multiple big data projects in domain like media entertainment, telecom, e-commerce, and use data quality not in all of them, but yes, at least in some of them, uh, applying the tool and leveraging the features. Then, okay, so that's about me, and then agenda for today is like we'll begin with a data story problem. Okay, and then we'll just know about the data quality introduction and the real time case studies. What could be the better data quality solutions? Of course it is going to uh, it is going to be suitable project wise, scenario wise, and the requirement wise, but we'll see, like at least we can touch base with some of them. And uh, um, and we'll see if we can solve data quality issues with Databricks and PySpark. And while choosing any data quality tool or while going through any scenario, what shall be the points that we should keep in mind doing the tool comparison, doing the POCs, and finalizing the tool in that case. Okay, so let's begin with the data story problem. Now, the first question comes is, what is data quality and why is it important and what can go wrong, basically? Okay, so by the definition, if we see that any data which meets the business purpose is a good quality data. Any data which has got certain degree or 100% degree of completeness in it is kind of an excellent data. Data shall be reliable, and above all it shall be accessible in timely manner. So, and what can go wrong with the data? If we talk about anything can go wrong and it could become a worst or a nightmare situation. Then, like for example, lack of validation routines, valid but not correct, mismatched syntax, format structures, unexpected changes in the source system, lack of referential integrity, data conversion errors, degradation in the transit. So anything could go wrong when it comes to bad data. So there was a report published by Gartner in 2018, and it mentioned that around 12 million dollars is approximate loss per year just because of the data quality issues. Pipelines are failing, and then false reports being generated and inaccurate reports being generated, impacting the businesses and all. So we see that it's very very crucial then. Now we talk about the story problem. Okay, so this is a real time story and it's coming from ebay labs. Then okay, what happened, like there are several teams within ebay, several departments, and they are consuming many kpis. Like for example, there is view item kpi, search kpi, new bid kpi, transaction kpi, and whatnot, and multiple teams involved. So for each of these kpi consumption, of course there is a sla set of 99% that it has to be like that. But in one of the KPI, what happened was that, for example, the search KPI, the index went from 99% to 77%. And when the team realized the data is not coming completely, then the team started looking for the problem. What is the problem? It was personalization team which was consuming the data. And when it comes to personalization, it is pretty important team, because the campaigns are set on top of personalization, and it could impact the revenue heavily. And when they realized that data is missing for search, then they went back to the streaming team saying, is something wrong, that why the data isn't coming, and we are not receiving the full kpi data. And then streaming started searching, and they said, like, we haven't changed anything, no field changes, or any change has been done recently. And they went back to the mobile tracking team, and eventually mobile tracking team mentioned that yes, there was a change in the data type they did, but they did not communicated it to the downstream team. And as a result, means like the changes in the field structure, it result in pipeline failure. And eventually there was no data coming for around this troubleshooting was like kind of 1 week it took, and they lost the data for 1 week. So why this happened? This happened because no unified view of data quality across multiple systems and teams, no platform approach to manage the data quality, no systematic way to measure near real time data quality. Okay, so of course, means like then they were able to resolve the situation by coming up the strategies or tools and all, but definitely means like it was a big cost to them. So what are the case studies that could come across? So in my previous from my previous projects, I have just collected certain case studies so that I can present here as some real time cases, that how we were able, what were the issues and how we were able to solve it, what we did, what were the strategy that we applied. Like this is a case from media and entertainment industry. That's a case study number one. So it was like client was having subscription based data. Okay, and this subscription based data was coming into the data lake from multiple sources like sap, oracle, teradata, and third party flat files or vendors. So it was coming like that, and data was having like null records. Even sometimes the subscription key was null, which is a major issue, because you don't know, means like what could go wrong with when you manually ingest the data from like when there is a human intervention. And invalid data types were there, the character length mismatched, like phone number with country code without country code, data duplicacy was there, invalid values were there. So what we thought, that we were having a layered architecture in the data lake. Like for example, it was layer 1, layer 2, layer 3. So we thought of where we are doing the data transformation, there we can actually implement the data quality layer. Okay, and then from the transformation layer, you see it goes to the aggregation layer. So that was a step 2. So we applied the data quality layer in step 1, and step 2 in the aggregation layer and the data transformation layer. And what we were able to capture, we were able to capture the data quality metadata. Like for example, what was the data sent by, how many rows sent by the sources, how many were ingested, what were the data types we were managing, what was the ranges. Like for example, something has to be in between, some numbers have to be in between, some regular expressions to be checked, some data discovery to be done. And we were able to build a dashboard on top of the metadata that we captured. Okay, and at the same time, means like to the presentation layer, it was of course the dashboard the business was able to view, but at the same time business was able to have the insights that okay, these many were the sources and these were the issues in the data. And they were able to find out who was like which team which data provider messed up actually, and how we can re-request the data in that case. So the outcomes were like replace the manual process for checking the missing KPIs, reached out to data providers with identified missing KPI data, created visualization for missing KPI month wise and week wise, and on time weekly SLAs, they were met. That was above all. The technologies that we use, the tools that we used here were AWS Deequ, that was Scala based, and AWS S3, of course, and Apache Airflow, Data Lake, Spark, Scala. Those were the things that we used. Moving on, that's the case study two. That was online retailer of apparel and fashion products. So in this case it was again there were multiple data providers, and then there was like weekly dashboard which was built from all the data providers to check that whether they had the data or not. So in this it was important that not only the data quality shall be there, but is the data complete or not. So for example, when they are viewing the data month wise, then January, February, March, for example, so they would like to see it this way, and if the data is present that for that month or for a given week or not, because they were viewing month and week wise both. So it becomes important to check that for a given week, was their data fed or not. So in this we were able to actually sort this out. It was all Google's environment, so we use like Google spreadsheets to consume the data, and we prepared a central repository of the checks actually, and we created a metadata out of it. Again, means like capturing all the information when the when the file came in, what were the issues and so on. And the notifications to the stakeholders and the data providers were sent through email notification and Google Hangouts as well. Okay, so it was like kind of Google Hangout APIs were integrated with the data quality, and we were able to publish actually uh, the 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 result, and soon we were able to capture the response of the data provider if something was missing. So we were able to measure the bad data, automated alerts to inform data providers with the identified bad records to correct the data, created visualization on data quality metadata, as I mentioned before. Overall improvement of the data quality that was we were able to achieve. Again, it was a S3 that we used, then custom Python based checks that we used, and it was on Databricks, and then it was PySpark. Uh, Going further, so I have like kind of collected a certain list of tools to showcase, like for example, what you can choose in your use case, what are the tools available in the market, and what could be the best tool as per the use case. So for example, this is from the open source community, and it starts from AWS Deequ. This is a tool which is Python based and Scala based both, and it is good for anomaly detection, auto suggested rules used by AWS Glue team actually within their data quality process. Then comes the Great Expectation. Again, it's an open source Python package validating data. It's primarily Python based. The data quality checks are abstracted as expectations. So you write the expectations and you validate those expectations then, and that's why it is a Great Expectation tool. Then there is a beta version of GX Cloud also in the market now. Apache Griffin, this is coming from eBay. It is more working on data at rest when you have already ingested the data, and it's again, it comes with a good UI as well. It's like not that much API based in comparison to DQ and Great Expectation, and you can configure your checks actually through UI in it. Then comes Soda Core. So it has got the paid version and it has got the free version as well. There are certain features which are present in free version. Some are only available in the paid version. So again, it could be one of the tool that can be leveraged. Then there is a tool called Collie. It is moreover, it seems like a copy of AWS Deequ in Python based, and it seems like this is more maintainable these days in comparison to AWS Deequ. And going further, here's a list of some license based commercial tools which are very popular in the market. And yes, most of them have good percentages, good share in the market, and companies are using them widely. Like it starts from Collibra Data Quality Observability, Data Quality Observability Platform, and custom and AI adaptive rules. It has got scorecard, potential synergies with our data catalogs. Soda.io, this is the paid version again, and it is like kind of in this version you got no code with SodaGPT, out of the box checks and checks as code, and Soda checks language. Databricks, of course, means like it is restricted to Delta live tables in Databricks, but again means like here it could prove to be a very good solution if in case if you have this particular tool. Then there's Monte Carlo. Haven't explored this much, but it sounds good for data observability platform, and pre-built. It has got pre-built custom metrics, anomaly detection, data lineage. Then there is a tool called Telmai, and again it is very similar to Monte Carlo, but it is like both batch and streaming use case. This can be used. Then now coming how we can use Databricks and PySpark together if we want to use Deequ. Okay, so first of all, what we do is we go to our Databricks notebook and we go to the cluster settings, and what we do is we need to install the Deequ library. Okay, so you see that I have installed Deequ 205 Spark 3.4. Okay, that was a version that I needed, and in case through it is through the Maven Central repository. And in case in your case, if you have a specific version to be needed, just go for that. So once this is done, the next step comes is we need to install pyDeequ using notebook. Like for example, pip install pyDeequ, and then this is done this way. In case if you want to go with the Scala environment, of course you can go, but this is something which I did with Python, so I'm showcasing this with Python then. Then in here, what I have done is I have tried to create an RDD, and then from RDD I tried creating a data frame. Okay, and this data frame I will pass on to the Deequ API. Okay, so you see here that some dummy values I took, and then I converted into data frame, and in that data frame dot show, you see that there's Java, Python, Scala, and there is a column that is underscore 2, and you have certain values over there. In the next slide, if you see here, pyDeequ, actually this tool Deequ has got multiple classes. Like for example, constraint suggestion is one of the class, analyzer is one of the class, and check is one of the class. So in here I am leveraging the analyzer class. So what I'm going to do is I will pass on my data frame to the analyzer class of this Deequ, and it is going to return me certain output that what was the analysis, and it will be in the form of a data frame. And then you can, if you want to modify anything within the data frame, it's up to you. So like for example, if you see what I have done over here is pyDeequ analyzer import star. So everything I imported from that class, and then analyzer dot analysis runner, and then I'm passing Spark, and then I'm passing my data frame. Okay, my data frame had two columns. So for the first analyzer, that is dot add analyzer, I'm going to analyze the size of my data frame. Okay, I know that there are three rows, but this is just for the showcasing. Then dot and add analyzer, and I'm going to check the completeness check actually over here for column number 2. Okay, and dot run, and then I'm going to create a success matrix and pass my data frame into it. And the success metric, this is the inbuilt class of Deequ, and then analysis result dot show. Okay, so you see what the Deequ is returning in that case. So it returned the data size which is 3, which was expected. And for the column, the check which I wanted to check the completeness for column underscore 2, its completeness, it's 100%. So 1.0 means it's 100%. If there would have been like for example 1 is something missing, then it could have shown that only 66% of the data is valid, while the remaining 33% is not. So here it would have shown 0.66 or something like this. So that is how it showcases, and at least it solves the purpose analyzing the data. So you can try this thing out with the constant suggestion as well, the checks as well. Okay, those are I would recommend certain very good classes to use within Deequ. Then this is great expectations over here. Okay, so this great expectation is actually slightly different, and it purely works on the basis of JSON. You input the JSON, you get output as JSON. Okay, and in here if you see, then I have tried to write my check, and it is called expectations. I've written my expectation, and for the first expectation is expect column values to be of type. Okay, and what is the type I'm expecting? So in here, my year is not int, it's a string type. Okay, so it's not integer, it's a string type, but anyways, it was dummy and I wanted to validate it with. So when I wrote this expectation and I passed it onto the data quality engine, and then I got certain result, and the result which I got was here that expectation info, this is a metadata which it gave, that raised expectation false. This means my expectations ran successfully. Okay, and the if you see in this line over here, it's slightly below, then it says success is equals to true. Okay, the config which I passed is coming here as column is equals to year and type is equals to string type. So the expectation was passed to check if the year was a string type or not, and it is successfully validated that yes, the year is of type string. Okay, and it has given a batch ID as well. This is very important over here. Just say you are running a batch, and you're running a job, and you want to just capture that which particular job yielded which check result, then I would say that the batch ID becomes very vital over here, and it is coming like as an inbuilt feature. In other solutions you have to kind of maintain your own batch ID, but great expectation, it by implicitly it returns a batch ID. So that's really good thing. And then expectation type is column value to be of type. Okay, so this is, but this is not a complete JSON. The JSON which is returned is a very long one, but I have taken only a part of here to show what was actually the input and what was the output. In the next slide, I'll continue showing what was the remaining part of the JSON. So if you see here, I have written another check on the left hand side, input check JSON, and then what I'm writing over here is expect column value, no, this one, expect column value to be between. Okay, so my column value is amount of refrigerants, the name of the field is amount of refrigerants, and it has to be between 0.1 to 500. Okay, and now when I input such a JSON, then what output I'm getting is it found the result and the element count. So the overall data set count, overall data rows which were checked for this validation were 283. Okay, and the success value, here you see the result was success true. So the my check passed because the value was somewhere complying between 0.1 to 500. Okay, and again you see a batch ID which was coming over here, and then what was the type which was passed was expect column values to be between. So this is how it worked. Yeah, and then going next is, yeah. So let's say, for example, you have seen now how PySpark, how Deequ works actually here, and the Great Expectation works over here. Now, when it comes to multiple tools, then what could be the parameters you should be looking at in order to check whether it suits your use case or not. So, for example, the threshold check. What is a threshold check? Like, for example, the minimum value you have to have actually in for a field. So in case of Deequ Scala, in case of pyDeequ, in case of Great Expectation, I've just created this comparison matrix. You see, works on basis of minimum and maximum value. This also works as same, works on basis of minimum and maximum value using expect column values in between. So something you need to write like this in Great Expectation, and it works like this. Then yeah, this is important point where what support you can get from this open source community tools. Then original team at AWS has broken apart and it's not being supported anymore, community seems willing but unable to develop further. At least on a frequent steady pace, it is not being supported. But great expectations, it's like continuously supported, since this is a open source tool. So, and at any point of time, if you have that much bandwidth, you take the code from the git, and then you maintain the code, and then you maintain the checks, and you put some engineers onto maintaining it, and then you can carry on like this. But if you expect support from AWS on this thing, or a community, then it's slightly difficult, but you might get it then. Constraint suggestion, you get it in both the category of tools. Then row based schema validation, in certain use cases it is very vital that they want to validate each row, not the entire data set altogether. So in Scala based, you can get in pyDeequ, but in the Python version, sorry, in Scala you can get, but in Python version it's not present, but you might need to extend it. So you have to code yourself. Great expectation, it's no. Programming language, of course, means like one is Scala based, and this one is Python based, and GX is of course Python based. Checks executed on data frame in Scala DQ. In case of Py, it's Python wrapper. In Python wrapper, it does not inherits all the features of the Scala actually API. But in case if you need something from the Scala base, then you need to extend yourself in the Python wrapper in that case. Okay, and in great expectations, checks execute on data frame, and it offers a very long list of checks. Then if you talk about the analyzer, like if you want to analyze your data, you get it in DQ at least. Then anomaly detection, you get all three of them. Then Python based, so you get yes, pyDeequ flavor you get in AWS DQ, and you get a Scala version as well. Great expectation is definitely means like Python based. Spark support you have in all of them. SQL support, you get less SQL support in DQ, but you get full SQL support in GX. Check result. So the DQ returns a data frame, but GX returns a JSON actually. So you need to parse the JSON every time to a data frame in case if you want to save it, or you want to make it more meaningful, or if you want to draw some insights out of it. Then documentation point of view, the tools, these tools like in case of this AWS DQ, they have got some good documentation, and they have done as much as they can describe in the Git repo. But in comparison to GX, I would say GX is very well documented, the documentation done. Then Pandas support. So Pandas support only comes with the great expectations, return invalid rows. Yeah, so Python does not, the Python flavor of DQ does not return, but Scala DQ can do that. Great expectation can also do that. And then return result format, yeah, that I already told, that's data frame and JSON. And then compatibility with Databricks, in case if you are looking only for Databricks, then all three of them have got good compatibility with Databricks. Slack channel is available for all three of them, Git repo available, and of course all three of them are open source. Then if it comes to the connection support, like for example you have Athena, you have BigQuery, you have MS SQL, MySQL, then uh, as long as they are supported by Spark, you can make the JDBC connection and you can use it in the Spark, then okay, DQ and pyDeequ are okay. But I would say great expectations score more over here because it has got dedicated connectors for all these uh, data sources actually. So that's really a good thing, which we can actually consider while choosing any of the tool. And that is, I would suggest that when you are trying to evaluate the tool, any other tool, means like these, some of these paradigms become very handy, and they help us to take the decision actually in order to select the tool then. So yeah, and these are the references. So for example, means like what all blogs and what all websites I have referred actually in order to prepare the material and what the use cases or case studies that I have prepared, I've just put a short link over here, and then yeah, that's it from my side. So yes, we have time for questions now.
Sorry, yeah, thank you, Deep. Very interesting presentation. Yeah, we have like list of questions, so let's discuss. Uh, yeah, you are work as a data engineer, and looks like you work with data quality tools. And do you think that every data engineer need to know them?
No, no, no. It doesn't happen like this. So in my case, it was kind of a scenario where I came across this kind of situation where I was given this task and I did that, and I did it nice. So that's the reason. Means like I got some knowledge onto it, but definitely in certain projects, sometimes QA teams are separate and they take care of this thing. But in case if you know this thing, then it's not an harm.
Mhm.
Yeah, and I would say means like why engineering come into this thing, because I don't know how much QA guys can get or can deep dive into such kind of tools where you need to have Spark knowledge, you need to have those basics, and then you kind of leverage those APIs, integrate it with your solution, and then you run the checks. So I would say it would require definitely a developer's knowledge in order to get into these tools.
Yeah, so we mean that uh, to work with all these tools, it's required to have knowledge of some programming knowledge, programming languages. Yeah, what kind of what knowledge and skills are else necessary for them to work with these tools? Do you
So
need to know like I don't know, like you mentioned, cloud services? Do you need to know AWS CLI, some DevOps tools, or
no, no, no. So for this, I think basically you just need is very basic Spark knowledge. Doesn't mean that you are running Spark on cloud or on-prem. Doesn't require. So if you just know, like for example, Scala basics or PySpark basics, and you want to leverage the tools, you can do that. Like for example, even for great expectation, if you are not from Spark background, you can use just simple Python. Then in that case, so that's very much possible. It's not possible in case of DQ or any other Spark based tools, but some of the tools are coming even GUI based, like for example Griffin. So even if you don't know this thing, you can do that. But uh, in not in all tools, in some of the tools you require specific knowledge, at least certain to up to a certain extent.
uh, okay, got it. And based on your experience, what do you usually do with invalid data? Do you just filter it, or you try to fix it, or you just invalid like the whole data, or you just stop pipeline? Uh, yeah, what do you usually do?
So this is a subjective topic because it depends upon your use case. So in my case, we were able to flag the invalid data. We never rejected it because our business did not allow to lose the data. Okay, so we flagged the data, but we kept it in the same table with a flag. Bad data is equals to false or true.
Mm.
Okay, that this role is not complying. But in certain cases it is required that if the data has been identified bad, then you put it into a separate repo or separate directory, and then you read it separately and you can send it back to the data provider. Okay, so this is depending upon your SLA, your business use case. So every solution is different in this case.
And can you share some examples how improving on data quality impacted the business outcomes and your project or yeah of your project or organization?
Yes, so actually, again, that is related to engineering stuff over here, and how that, for example, we are consuming the data. Okay, and when it was mainly Spark that we were using, and for example, if the data is coming null, and the data has several issues, then it impacts the pipeline, it starts failing. Okay, so that's the reason. Means like we didn't want to fail the pipelines, we put the validation that can check apply the data quality rules in the fly and before saving the data into our data lake. So that way we have some good quality data uh, from the source into our system. um, Reduce the pipeline failures. So as many pipelines are less pipelines are failing, the less number of tickets are being generated, the less number of support help is needed in that case. Because we at the same time, like in past we were having like 20 tickets in a day, and it was reduced to 2 tickets in a day. Okay, so the ticket volume shrunk. And when you have so many null values actually, or so much inconsistent data, especially when you are using Spark engine and you apply the joins on that thing, and you know it can create a nightmare. How? Because the Spark job starts taking too much time because of the uneven partition that they are carrying inside. Okay, so some of the Spark partition will have more data, some of the Spark partition will have less data, and the data will be skewed. So you need to avoid that thing, and that's why it becomes very important then.
Uh, y- yeah, got it. So also in your cases, you mentioned that you send some notifications with test results. And yeah, could you give some more details about these notifications? What they included? Like, was it like, hey, data quality checks failed, or some numbers, or maybe even data sets? So, can you give some suggestions, advice, how to prepare proper notification, not to overload it, and yeah, quite informative.
Okay, so of course means like the for the word overload, we need to send the notifications only for the failed data. Okay, for the success we can avoid. Nobody knows wants to know, but something which has failed wants to get attention actually. Okay, that's number one. We can reduce the noise by that, and then means like of course the notification would be there. What kind of notification you want to set is as per your business. For us it was Slack channel in one project, in other project is what it was Google Hangout, it was email notification. We prepared a separate email account for these notifications actually. And the business line were defined for us, like to whom this notification shall be going, from the data providers list point of view to the stakeholders list actually. And then the we had like kind of these chat groups where the reports were being sent. We tried to keep the report as short and to the point as much as we can, rather than showing the details. We provided the link actually, and in the link if you click, it was a hyperlink, and then if you click on the link it will redirect you to a HTML page, uh, where you can see the metrics in detail actually, that which month, which week, which year the data was missing to by which data provider. So this way actually you can keep the notification crisp and detailed at the same time, by not putting all the collated information into the mail or chat alert, but rather providing some hyperlinks, and it is redirecting to somewhere then, this way out.
Okay, got it. And but yeah, all these tools that you mentioned, they're not creating any reports and HTML pages as you mentioned. So you have to create like your own solution on this part, on creating reports, right? Or you maybe already use some cloud services for that.
Yes, that is true. That comes the effort to oneself only. So that's I would say none of the tools free, at least in the open source tools, you or the API based tools are not going to provide you. So once you are creating a matrix, actually, like for example, if you use DQ or if you use Great Expectation, you see that they are returning certain metadata. You capture this metadata into your tables. Okay, and you create a dashboard out of it. So that is what mostly the teams are doing at their end. But it is like kind of, you would be very lucky in any of your tools if they provide you actually this as a inbuilt tool. But I've never seen it as inbuilt. It is like we have built on our own most of the time.
Hmm. Yeah, and regarding creating own solution, I heard that data quality engineers, or maybe yeah, engineers in general, prefer using custom frameworks. custom DQ frameworks. So how can you compare listing tools with creating own frameworks?
Yeah.
What
So
are the advantages of maybe using those tools that you shared with creating custom frameworks? Or maybe there is no like sense to create custom frameworks since other people already create
Okay.
tools.
So yeah. So in this case, I would say I'm never in favor of custom tools. Okay. Only if there is a dire need of the one to create. The reason behind is that everybody is running short of time and they have a lot of work and everything was supposed to be done yesterday. Okay. Keeping all those all those things in mind, if you start creating custom tools, then there is a lot of head that you are creating for yourself. The reason behind is, if you take a deeper look of DQ, then you get that you don't only get the checks, but you get the constant suggestion also. You get the check matrix, you get the analyzer class also. So many things that you can leverage out of these already provided open source APIs. Okay. Now if you sit down and you start writing your own checks, then you would be only able to write the checks, but if you need anything out of the box, then again you have to write it and you have to maintain it. And if you are out of the project tomorrow, then the person joining new has to maintain it. So we don't know how much enthusiasm the newcomer or the new team would get, but again it is a lot of overhead to do write the checks of their own. So means like at the same time, if somebody some other company is maintaining the tool in a dedicated manner, then why not to leverage it, and you're getting a lot many features actually on top of it, not only just simple and plain checks. uh, but means like if there is a conflict between the data quality team and the developers team on this, that okay, no, we are going to write their own checks, then we cannot have any other third party tool. Then in this case I would say it more depends upon the project scenario, that what is the business requirement and what is the business priority then. So yeah, it's again subjective then.
Okay, interesting. Yeah, and also I mentioned interesting tool. It's called Soda in your
Yeah.
presentation. So and it's SodaGPT. That sounds interesting. Could you give more details about it? How does it work? Does it generate some SQL queries or code?
it
What exactly is it?
generates the checks for you. It generates the check for you. So I haven't, it is in only in the paid version. You can go to soda
Ah,
library, you can have some more information over there. But since it's integrated with means like they have integrated it with chat gpt and they call it soda gpt now. So of course, means like if you do some input, then it would be able to generate the checks for you.
mm-hmm. Yeah, good. We also have a question. If data is ingested from multiple sources, is there a tool to extract metadata of all incoming data?
So of yes, in actually there are certain APIs, means like within these tools, not all of them have, where they generate the metadata for all the data which is being passed. Like from the metadata point of view, what would you like to capture? It depends actually. So you want to capture the overall row count that you are getting. If you want to capture the data types, if you want to capture any of the like for example mean, median, average, if you want to capture. So some of the APIs do provide, like for example Apache Griffin is the one where you can analyze all this information. But if something more is needed, then you might have to extend it yourself then.
Uh-huh. We also have one more question. As a data engineer working mainly on ETL or pipelines, will DQ also give me edge in the career? And what are the challenges you face or hardest thing solved so far? So probably, yeah, will data quality tools like help to grow in data engineering career?
Yes, they do help from not from, they are not going to give you instant result. So it's not like that. But I would recommend that if you are exposing yourself into this direction as well, then it's a good thing, because from the longer perspective, future perspective, uh, so you today you are an engineer, but tomorrow you have to be growing in your position. And if you look yourself from enterprise point of view, enterprise architecture point of view, or senior architect point of view, then you are not only limited to the scope of pipelines, but you need to know what is going on in the other streams as well. Okay. So it's important that if you know this aspect, then definitely it is going to aid you in future then.
Okay, yeah, that's it. And I think that concludes our session. Thank you all so much for joining us today. We hope you found the session insightful and inspiring. In the video description below, you will find the link to the talk page where you can provide your feedback on this talk, give speaker a badge, and rate the session if you like or if you don't like it. Your feedback helps us to improve future events and recognize the hard work of our speakers. Additionally, if you'd like to revisit it, you can download the presentation file on the talk page. So check the video description on the link. Thank you very much, Deep, for coming. Uh, it couldn't happen without you. So thank you.
Thank you, Alexander, for inviting, and thank you all for attending the session. See you. Bye.
Thank you. Bye.